कक्षा 11 का विद्यार्थी भाइ बहिनीहरूलाई लक्षित गरेर आज हामी ग्यास लज को पार्ट 1 लिएर आएका छौं र यो कक्षा 11 को लागि फिजिक्स एज वेल एज केमिस्ट्री बोथ सब्जेक्टका लागि इम्पोर्टेन्ट हुन सक्छ। त्यसकारण यसलाई राम्रोसँग अध्ययन गर्ने प्रयास गर्नु होला। मेरो केही कमजोरी भए कमेन्ट मार्फत सल्लाह दिनु होला, म आफ्नो कमजोरी सच्याउने छु र हामी ढिला नगरिकन सुरु गर्छौं। ग्यास लज Gas laws means the behavior of the gases, the behavior of the gases with the relation between three important parameters such as pressure, volume and temperature. This is the definition of the gas laws, and within this subject we have the very different types of the gas laws, but in the today's section we would discuss only Boyles law, Charles law and the combined gas equation. First we start with the Boyles law. The volume of a given mass of a gas, the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. Mathematically, volume of a given mass of a gas is inversely proportional to the pressure, but at constant temperature. This is all about the Boyles law. Now for the Charles law, the volume of a given mass of a gas is directly proportional to its temperature at constant pressure. Mathematically, volume of a given mass of a gas is directly proportional to temperature, but at a constant pressure. Now, in order to obtain the relation for the combined gas equation, we need to apply both Boyles law as well as the Charles law. So, for simpler manner, you need to make a concept clear about these two laws, that the volume of a given mass of a gas is inversely proportional to the pressure. This is the Boyles law. And Charles' law is volume of a given mass of a gas is directly proportional to the temperature. When I'm combining these both equations, that is when we combine the Boyles law and the Charles law, then we get the relation of the combined gas equation. From Boyles law, volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. This is the equation number first. Now from Charles' law, volume of a given mass of a gas is directly proportional to temperature at constant pressure. This is the equation number 2. Now we need to combine both the equation first and second. Combining equation first and second, we get B is proportional to, we need to be more careful here. In one part there is inversely proportional to P, and in other part there is directly proportional to T. So it is P upon P, or PV is directly proportional to T. Therefore PV equals to KT. This means PV upon P equals to a K. This is called a proportionality constant. Or it is also called specific gas constant. Specific gas constant whose value depends upon the quantity of the mass. So now we want to have a general concept in order to have the relation between the two different cases. If P1, V1 be initial pressure and volume, T1 be the temperature, and in second case P2, V2 be the final pressure and volume, and T2 be its temperature. So in the similar manner of PV upon T equals to K, we can write P1 V1 upon T1 equals to K. This is equation number 3. And P2 V2 upon T2 equals to constant. This is the equation number 4. So combining three and 4, we get P1 V1. When we combine the equation 3 and 4, finally we get P1 V1 upon T1 equals to P2 V2 upon T2, which is called combined gas equation. Now in this part we also discuss some of the numerical problems that are related to Boyle's law and Charles' law. We have the question of a vessel of 120 ml capacity. This is the volume. Contains a certain mass of a gas at 20 degrees Celsius. This is the temperature. and 750 mm of Lg is a pressure. Here we have given the three parameters. So it is the numerical problem belong to the gas laws, because we are explaining in the definition that if we have the three different parameters, that is the pressure, volume and the temperature, then it is the numerical belongs to the gas law. Then this gas was transferred to the vessel whose volume is 180 ml. Here we have given the two datas of the volume. First one is initial volume 120 ml. Initial volume V1 equals to 120 ml. Final volume V2 equals to 180 ml. Now we can add it up in this numerical problem. We need to calculate the pressure of the gas at 20 degrees Celsius. Please be careful while handling the numerical problem. We have given the some clues in this question that this numerical problem is belong to the Boyles law because the temperature is constant. Here it is 20 degrees Celsius and here is also 20 degrees Celsius. So if it is the numerical problem of the Boyles law, then we can use the relation P1 V1 equals to P2 V2, and we have given the initial pressure P1 equals to 750 mm of Lg. So we can get the final pressure from here. Final pressure P2 equals to what? Okay, from Boyles law, P1 V1 equals to, please give me a calculator, P2 V2, or P1 means 750 into V1, that is 120. We need to calculate P2 and the value of V2 is 180, or P2 equals to 750 into 120 upon 180. Therefore, P2 equals to 500 mm of Hg. Nitrogen at 27 degree Celsius are cooled to minus 20 degree Celsius. We need to find the new volume. But in this question, the pressure needs to be fixed because it was not given in the question. So we need to know from the question that the pressure is the constant means, because there is no any value of the pressure given in this question, but we have given the two different values of the volume. Initial volume was given, final value we need to know. Initial temperature was given and the final temperature is also given. So initial volume V1 equals to 200 cc. Initial temperature T1 equals to 27 degrees Celsius. So we need to convert it into the Kelvin. That is 27 plus 273, 300 Kelvin. Final temperature is minus 20 degrees Celsius, that is 273 minus 20, that is 253 Kelvin. So in this case we need to apply the Charles law because the pressure is constant here. Further, Charles law, V is directly proportional to T. So V1 upon T1 equals to V2 upon T2, or V1 is 200, T1 is 300, V2 we need to find out, T2 is 253. So we need to crisscross here, or 200 into 254, V2 equals to, that is 168.67cc. Okay, student, for the part 1, this much only. If you have any doubt or confusion in the other gas laws, such as the Gram's law of diffusion, combination of the ideal gas and the real gas, so we can come with the other parts in another part 2 of the gas law. If there is any confusion, please comment on it and don't forget to subscribe my channel.